So I'm George Annor. I'm at the Food Science and Nutrition Department at the University of Minnesota. And I work on wheat quality, as Melissa said, and I work a lot with Jim Anderson to look at the quality of wheat. So in this presentation, I'll be talking about the provision of rapid end-use quality characterization services to the University of Minnesota breeding program. And this is funded solely by Minnesota Wheat Research and Promotion Council. Okay, so we all know the University of Minnesota breeding program. They've been involved in wheat breeding for years. They want to release very good wheat varieties that have good yields, good crop, good pest resistance, and all the good stuff that they look at from a breeding perspective. But also, we also have to look at the good end-use quality characteristics. So from the end-use quality characteristics standpoint, we have to develop comprehensive end-use testing capabilities to be able to look at this. So we all know the farinograph and the mixograph is used for looking at the water absorption, for example, of wheat. But these tests, if you know about these tests, they are very laborious to use. They take a lot of effort to run. And when I started working at the university in 2016, I talked to Jim Anderson and said, hey, Jim, how do you determine or quantify the end-use characteristics for all your varieties? And he said, we normally send them to the ARS lab in Fargo to test the farinograph, to use the mixograph to test these varieties. And then I said, so how soon do you get the results? And he said, it takes years. He's always 1 year behind with the results that he needs to be able to select for wheat varieties that have good end-use characteristics. So I decided to work with him to do something about this. And as Walid said, if you're working with breeders, it's all about the numbers. They work with numbers, they are looking at thousands of varieties, and most of these farinograph and mixograph were built for analyzing 1, 2, 3, a few varieties, so they are normally used at the end of the breeding program. So what happens is that Jim Anderson will do all his breeding and will never look at the end-use quality characteristics, but will only look at them at the final stage, which means he may miss some varieties that are actually good or maybe good for baking properties. So I decided to work with him on this. So the development of these rapid tests I thought was very essential for the breeding program. So Jim and I decided to do something about this, and an equipment that we decided to work on was the GlutoPeak tester. We simply call it a GPT. So this was developed by Brabender, same company that makes the farinograph. And what actually also made this project very essential was the mixograph that has been used for years and years and years. The company that actually makes them, they have stopped making them. In fact, they have stopped providing services for the mixograph. So it means anybody who has a mixograph right now won't get any more parts when they break down. So that became something that was urgent for us to figure out another way to still be able to look at end-use quality characteristics. So we came up with the GPT made by the same company that makes the farinograph, Brabender. This equipment is very, very useful in the sense that it still measures gluten quality, just like the farinograph does, right? It measures gluten quality. One of the advantages is that it's a very quick test. 1 to 10 minutes, you're done. And you can use whole grain, right? For the farinograph, you have to mill your wheat and get the flour. You need large quantities. For this test, for the GPT, you need just about 3 to 10 grams of sample, which means that wheat breeders can essentially harvest grain just from one plant. And we can test for wheat quality. And that was one of the problems for Jim. He never was able to get just grains from one plant. He had to do a seed increase and just wait for years and years and years. So that was very essential for us. And the test is pretty much very automatic, very simple. You mill your sample 3 to 5 grams, 3 to 10 grams. We actually use about 8 grams. You put it in this device, and it pretty much does everything for you. So this is a short video of how it works. I hope I'll be able to get it running. Okay. Oh, all right. It's going up. So a short video of how it works, very simple. And I'm not here advertising for Brabender. They haven't paid me any money to do this, but it's just the equipment. So this is how the equipment looks like. It comes with a software, and you have to switch the machine on for a couple of minutes to warm up to, I think, 36 degrees. This is the same temperature we use for the Brabender. We use about 32, but you have to do that. You weigh your sample. So it comes with a bowl. So you weigh your sample in that bowl. And then you add water to it, just like we do for the farinograph. So you weigh about 8-point-something grams, about 9 grams, very small amount of sample. It comes with a very simple software. And then, so you just follow the instructions. You put your bowl in there. This bowl has, or they call it the cup. It has a spindle that actually spins up the wheat. So this is the paddle. It actually spins the wheat flour at a very high speed, essentially separating the gluten from the rest of the flour and characterizing how the gluten develops within 10 minutes. And then you get a result. So we'll see how it works. You put your flour in there. And then you just close the machine. And then it spins in there. And then you get a graph like this. You see the graph in real time. So you get a graph like that. And pretty much this is the viscosity that the gluten gives out when it is being spun at very high speed. So it's a very simple graph. A couple of minutes, you're done. In fact, you can run the test. The whole test takes like 5 minutes, but you can run this test at about 20 seconds. In fact, in my lab, we are able to run about 40 wheat samples in a day. You cannot do that with a farinograph. 40 samples on a farinograph will take you weeks. Okay. So it is able to separate the gluten from the flour and aggregate them through its mixing action. And this here is a publication that was put out from the GPT, and you can see clearly how it can distinguish between whole flour and refined flour. And even within the individual whole flour, you can distinguish between hard wheat and soft wheat. Hard wheat will develop very quickly, and then it will have what we call a higher peak, a higher torque. Soft wheat will develop slowly, right? So with this 20 seconds of run, we are able to distinguish between different kinds of wheat. And this is what Jim Anderson wants. But again, what does this say? When you run the GPT, we measure what we call the peak maximum time. So this is the time that you get the maximum peak. We also get what we call the maximum torque, and we get the aggregation energy. This is the area under the curve. Okay, so what does it mean when it comes to the end-use quality of wheat? So what we did in 2016, when I just started, was to work with Jim Anderson to find out a way to use the GPT, which takes 20 seconds to run, to predict the parameters from the farinograph. So essentially, instead of running on the farinograph for days on end, we want to run on the GPT for 20 seconds, but still be able to tell Jim Anderson what the water absorption is So we took some samples that he grew in 2 different locations, Crookston and St. Paul. We measured their dough properties using the phyronograph. These same samples, we measured their protein aggregation kinetics using the GPT, and then using regression models, some statistics. I'm not a statistician, but we were able to develop models that allowed us to predict the water absorption for these different flowers using the GPT. Okay, so every year we get hundreds of samples from Jim Anderson. In fact, just a couple of weeks ago, we got 500 wheat samples from Jim. 500, okay? If these samples are sent to the ARS lab for phyronograph, Jim would have to wait at least for more than a year to do this. Each year we get a lot of samples. So far we've screened more than 2,500 wheat samples for Jim Anderson. Okay, and this here is the 500 samples we got from Jim, planted in 2022. I think he planted them in New Zealand. So we normally don't know where these samples come from. We get them, and we immediately go ahead and screen them. This here is the predicted water absorption for all these varieties. 500 of them, we screened this in a month, 1 month. So we give the samples to Jim, and now Jim can look at this predicted water absorption and then select not only for yield and for crop for insect resistance and all, but also for the water absorption. For wheat quality, water absorption is very critical, and we don't want to lose out on wheat varieties that would have very good water absorption. This also allows us to pretty much follow to see, look at the water absorption year on year to see whether there's any changes. We've heard a lot about drought. Okay, did the drought affect the water absorption? We can easily screen these samples within weeks and have an idea what happened. This here is another sample, set of samples, 280. James sent this to us 2 weeks ago, and we already screened all of them for water absorption. So now James has all these water absorption values, and he would be able to use them for his breeding purposes. The regression model we did was for Minnesota. I will be very happy to do this same regression model for North Dakota so that we can have like a regional screening means to be able to look at the water absorptions. So we will continue to provide these services, thankfully with support from you guys. We are able to do this for the wheat breeding program. Luckily, we are not asking for any more money this year because last year the samples arrived late, so we still have the money we got from last year, so we just would continue to do this. It's a lot of work, but it's not crazy expensive. I mean, $15,000 to screen thousands of samples, that is not a lot of money compared to how much it would have cost us per sample to use the phyronograph. So I would like to thank you guys for continuing to support this. I think it is a very essential service for the University of Minnesota wheat breeding program. And as far as we have funding to do this every year, we will continue to provide this service. We are happy to expand the service to other regions so we can really start collecting a lot of data on the water absorption. Another thing that we are interested in doing is to be able to get all that mixograph data that has been collected over the years and try to use the mixograph data and the GPT to be able to predict the parameters that we get from the mixograph. Because when the mixograph goes out from the system, all that data that has been collected would be useless. So is there a way to still be able to use the GPT to still predict some mixograph values? That would be something we'll be interested in doing. So thank you very much, and if you have any questions for me, I'm ready to answer them. Oh, there's a lot of questions. I'm in trouble.
Thank you, Dr. Annor.
Nice talk, George. Thanks. It's great that the Gluto Peak is able to
use a single plant and actually get a measurement with just that small amount. I'm wondering what variability do you observe in the same trial with different replicate blocks, for example, the same variety, the same plant. Do you know what variability? And then in different environments from that same variety.
So we would have to do that analysis with Jim. So we do the screening, we send the samples to him, and then he uses it to look at these differences you are asking. So it's something that I can work with Jim to try and figure out whether it's able to detect those differences within varieties from the same plant. But I guess we should be able to do that. Yeah.
George, in a way, you answered it already, I think. So when we have really hot grain fill periods, the ratio of gliadins versus glutinins changes, which make up the two parts of what we call gluten. The gliadins get more predominant. Are you worried, or in your model, have you adjusted for, in your regression model, for hot years, cooler grain fill periods? Are you not worried about that because you're looking only for comparisons within that particular year?
Yes, it is something.
When Jim gives you 500 samples, they're all F5s, and he tries to decide which of those 500, which 400 he wants to get rid of.
Yeah. So the samples that we always get from Jim, they always come with check samples. And consistently, those check samples have yielded very, very similar results, right? So to your point, it is something that we actually have been interested to look at, especially with all this drought happening now. Could we tell a difference between the effect of the drought and its impact on water absorption? In the past, we couldn't do that because it took years to analyze those samples. But now with the GPT, we can easily screen varieties from different years or varieties that have gone through a drought and see whether it's actually impacting the water absorption. It's something we can easily do now.
Because, and this is for you guys, not that I'm, one of the things when it comes to marketing your wheat is that gluten strength and basically water absorption, which are the two main drivers in many ways in hard red spring wheat, there is no good way, as you heard, to do that at the elevator level. Even the Brabander, the quick peak test would be too long if you're in line with your truck. 10 minutes, you add that up in a day with the number of semis coming through, that doesn't work. When you can cut that time down further, where you only have to run that for 20 seconds, now that becomes a much more feasible technology at the point of receipt, which would be the elevator. Mm-hmm. That's why I asked the question, just in case you're wondering why I was going down the rabbit hole of hot versus etc.
And the other thing we also have been thinking about is, could we develop NIR calibration curves based on all this water absorption data that we can now generate within a short period of time? So we want to get to a point where you can also get some indication of water absorption using the NIR in addition to just the protein content. So now that we can screen a lot of samples for water absorption, now we have the ability to do that. So maybe next year it will be something that I may put in as a proposal to start looking at that. But now we should be able to do it.